Hello, our group is called Analysis of Breaches in Medical Records by Shayan Karowadia, Muhammed, Naail Momin. TA is Taher for Dr. Koda's class of Engineering 1331. Our group had the opportunity to learn about how we need to secure cyberspace in society and throughout. Securing cyberspace has to do with how we protect our health information, banks, and national security. One of the great challenges engineers face is the ability to secure the cyberspace itself. Ultimately, we want to protect all the factors throughout our lives, whether it be computing, our records, or any type of security. It is necessary for engineers to provide solutions that address cybersecurity priorities. The struggles with securing cyberspace revolve around the lack of security, protection in programs, user identification in hardware and software, and failure to protect the breaches in data flow. These challenges alone are not easy to spot, but are harder to provide solutions for. Engineers must understand that cybersecurity systems depend on the understanding of safety throughout the entire system, along with the technical aspects of cybersecurity. To fully develop a secure system, it is necessary to implement studies of psychology, social, and political factors. In this challenge, engineers need to know more of how the hackers and breachers personally interact with these cyber networks. Another aspect we need to know more about is developing new forensics to find criminals who commit cyber crimes. As engineers, we shed responsibility on the technology aspect of cybersecurity that protects cyberspace from being hacked in innovative ways that could detect problems in computer systems. The goal of our group was to find a way that we can help hospitals and medical research facilities prevent these cyber attacks. So what we did is we got information from multiple hospitals in the California region, and within those regions we try to find the different types of cyber attacks that were taking place. With that in mind, we wanted to analyze how these attacks are taking place, to what account, and how many people were being affected in these hospitals. With all the information we have gathered, we decided that as our group, we are responsible to secure these hospitals so they can have a safe and secure network within the patient and the hospital and overall and throughout. With that in mind, we want to make sure that our program does a well job of understanding the breaches of these hackers and using that to help educate these hospitals and give them solutions to how we can further stop these cyber attacks and secure the system. Going into this project, our group understood and realized what we had to do, and we decided that the purpose of this project was to create an analysis of these different type of breaches and create a way to educate these hospitals and give them a solution that will ultimately give them a better idea of what they need to do in the future and provide a more secure network. After we give the solutions, our group decided that we needed to give a representation of the annual projection of the patients affected per hospital. With that in mind, after the solution had been implemented, we decided to give an 80% slope, meaning that the original graph has a declining slope representing how the solution has made a difference.
So the next part that we're going to look into for our NAE project on securing cyberspace is going to be our algorithm and code logic. This is important so that we are able to give people an insight as to why we did and we coded the code the way we did. We began our code with our housekeeping commands. This is so that if any program or script was run before ours, that it is all cleared so you have a blank slate and there is no interference with variables or any of the data that we have inputted. So the very next step for us was importing our XLS file, which was our data set that we had found. In this data set, to import it properly, we used 3 variables within a square bracket that we set equal to the XLS read of the file name. Now these 3 variables were num, txt, and raw. Num was able to store all the numerical data that was stored within the data file. txt stored all the text data, and raw just stored the raw data. This pretty much gave us a separation and the ability to index properly. We continued on to use the unique function to filter each type of incident. And so this gave us pretty much a more concise and complete list of the type of incidents that occurred instead of just the full-on list. We then stored these different types of incidents within a menu that the user would be able to pick what type of incident that they wanted to look into more. We validated the user selection by making sure that the user did select a type of incident. If the user did not select a type of incident, then there would be no point of the code continuing. We then outputted the number of times that the incident occurred that the user had selected through the use of a count function. We then used the find function to isolate incidents of that type. Once we had found that, we used that to index the values of the number of people affected and use that data to create an average. Now this average is very important because this will allow any further data to be checked against the average. We then determined a range in which we were able to determine the severity and the type of security upgrades that that institution would need to implement to have a better chance of preventing such things in the future. So, having that information, we used nested if statements to determine the severity and the type of breach chosen to give the user some recommended security upgrades and to let them know how severe their incident is compared to those in the same category. We outputted this information to the user, and then we gave the user the option to run the simulation with the data that the user wants to input. Now, with the user input, we wanted to validate that it was proper and concise information that we could actually use to give them a recommendation. So we repeated the steps of determining the level of severity and the type of security breach, and we gave the user the ability of following our recommended security upgrades. After that, we gave them the output and gave them also a 12-month projection for the user inputted data for their own personal event. This pretty much gave them the ability to check and make sure that everything is running smoothly and that how their changes in security will be able to give them a more secure and stable environment for their information.
For our code, there are multiple test cases with multiple outputs that rely on the user's selections and inputs. Our code has a user make a selection from a menu of the type of breach incidents and allows the user to enter information on their own breach if they would like to. For the first test case, which is shown here on the poster, the user made the selection to receive an analysis on the hacking/IT incident type of breach. Following this incident, the user receives an output of the number of occurrences of that type of breach. In this test case, the user was presented with 358 number of occurrences for hacking/IT incident breaches. The code isn't done with the user menu selection just yet. To give the user a more detailed analysis other than just outputting the number of occurrences for the selected type of incident, the code goes on to further identify the severity of the breach, recommended security upgrades, and the urgency of the upgrades. For the test case shown, the user is presented with the information that their selected incident, hacking/IT incident, is of critical severity and critically requires a rework of the entire security system to prevent the same breach from happening again. Continuing with the test case shown, the user is able to further interact with the code when prompted to enter information on their own breach incident. The code then takes this information to formulate a similar output as earlier. The user inputted information is compared with the data from the health information breaches to give the user an analysis of their breach incident. In the test case shown, the user inputted that 6,000 individuals were affected in their breach and received an analysis of their breach that was of low severity, and a simple software update can prevent the breach from reoccurring again. Furthermore, the code takes the user's inputted information to develop a 12-month projection depicting a decrease in the number of individuals that would be affected if the breach were to happen again, if the recommended security upgrades were taken into consideration. The code is capable of many test cases, which all depend on the user's selection and inputs. For example, if the user was to select a loss type of breach incident, then the user would be presented with the information that the incident is of moderate severity and requires a firewall boost as well as a software update to prevent this type of breach incident from reoccurring. Also, if the user were to input that 200,000 individuals were affected in their breach, then the user would be presented with the information that their breach was of critical severity and requires an entire rework of the security system to prevent this type of breach incident from reoccurring. The code is capable of analyzing 26 different types of breach incidents, over 1,500 different occurrences of breaches, and an endless possibility of user inputted information to present the user with information on if the severity of the breach is low, moderate, high, or critical, if the recommended security upgrades are a software update, a firewall boost, a new method of data encryption, or if a rework of the security system is needed. The code has a few limitations on it, one being that while it can be used to offer methods for prevention of security breaches, it doesn't actually advance the security system itself. The code is more of a diagnostic to security issues with an analysis. Another limitation that the code faces is that it is not able to give a recommendation on a specific brand of security upgrades. With technology ever so growing and improving, hackers are attempting to find new creative ways into breaching information. Having such a code available that is flexible to change, users can be informed on methods for preventing breaches in their systems for years to come.